Hello everyone. I hope all of you are doing really well. Now it's been a long time I haven't posted any videos on my channel basically. So today's video is going to be related to the board exams which are scheduled to begin in in the month of March first week or maybe February end, right? So I'm basically focusing on class 12th board exam, that is the state board, Maharashtra state board. Okay, so this series is going to be ace the board exam because you know what, most of you might be preparing very well for your entrance exam. So many of you might have already, just left out the preparation for board exam and moved pretty much ahead. Now you might be realizing that it is really a hard time for you now if you don't start preparing for the board exams, right? So most of you might develop some sort of discomfort here and there. So in order to make sure that this discomfort is completely removed, you need to have certain important concepts actually at your fingertips, right? So basically, what I'm going to do is I'm going to discuss how you are going to prepare for these exams, okay, board exam, topic wise. What are the things that you should study, and mainly how much time you should allot, okay, so that you can do this without any discomfort, right? And also I'll be discussing the important end of the textbook questions, which are already there in your standard textbook. Okay, so now let's begin. So I'm going to start with the chapter on halogen derivatives of alkenes. Okay, so this is basically the first chapter on organic chemistry of class 12th. Okay, so now let's try to understand how you are going to prepare for this particular chapter, because this chapter is one of the biggest one in the entire in the entire textbook. That's what I can say, right? So you what you could do is, simply preparation for your board exam or the entrance exam, you can divide it into four parts. Of course you can have your own strategy, but I believe this really works very well. Okay, so what you could do simply is, you can just divide it into four parts. Okay, and each part has to be unique, it has to be short, and you need to understand what are the things that you should focus more on. You don't need to study the entire topic, right? Now the first part is going to be alkyl halide section. On alkyl halide introduction, every one of you know, you could just go through a few set of MCQs that are related to introduction, wherein they normally ask which is the type of alkyl halide, right? Allyl, benzyl, vinyl and all. And then preparation methods, you could focus on the Markovnikov, anti-Markovnikov methods, and ring expansion, whatever you can have it, right? So in state board they don't ask too much of details, but yes, in entrance exam there are a lot of questions related to ring expansion reactions, right? And generation of more stable carbocation rearrangement reactions and all. Physical and chemical properties, something related to the physical constant, that is melting point, boiling point, reactivity, and the chemical properties, right? The reactions are pretty much simple, that you could do it, like nucleophilic substitution, and then elimination reactions and all. This could be covered in part one. You can just, when you are preparing for this topic or when you are revising this topic, you could divide it into four sections or four parts, and part one should not take more than 30 minutes if you are completely thorough with this chapter, right? Then let's talk about part two, which is going to be optical activity. Now you can go through the set of videos that I'll be providing it in the description box, okay, related to optical activity, and then RNS configuration. Even though there has not been any questions related to RNS configuration in the end of the textbook questions, but you could still have an overview of what exactly these are and the different steps, right? And something related to the stereochemistry, that is retention, inversion, and the enantiomers, diastereomers and all, right? So you could have a little bit of stereochemistry. Now this part 2 should not take much time, but you just have to make sure that whatever you are doing it with proper understanding. Okay, now let's talk about the part 3, which is the most important part. Now SN1 and SN2, you have to do it properly, because a lot of questions from the entrance exam are asked from this particular section, that is the SN1 and SN2. Don't do it just understanding like these are the things that you're supposed to know. Try to solve as many questions as possible, because it would be very helpful for you in your entrance exam as well, even if it is MHT CET, right? So do the factors affecting, what are the influence of solvents, nature of substrates, nature of leaving group, do everything together. So part 3, it's just two concepts like SN1 and SN2, should not take more than 30 minutes, right? Now let's talk about aryl halide, which is the shortest part of the topic. Now in this aryl halide, you could do nature of carbon halogen bond, and you know what happens, it develops a partial double bond character and all, right? And do Wurtz fatigue reaction. Now, in previous papers, you might have already seen that they emphasize a lot on Finkelstein-Schwarz reaction, Wurtz fatigue reaction, Sandmeyer's reaction. So, try to do all these things and even start solving the questions which have appeared in the past 5 years. Even though syllabus has little bit changed and they have modified a lot of things, but still you could do it, right? So, part 4 should not take more than 20 to 25 minutes. So, I'm not asking you to do everything in one go, but at least you still have a lot of time for this particular topic. You can just divide this into 4 parts and then do one part every day in a proper manner, so that it becomes actually the last minute revision for all of you. Right, so you could have your own strategies, but I think dividing this into 4 topics and 4 parts and then doing one part at a time is definitely going to be very much helpful for all of you. Okay, so you can have your own way of doing this, but I think this is one thing which I would suggest. Okay, so now let's do the remaining part. Okay. So we have the first question. Okay, which of the following is likely to undergo racemization during alkaline hydrolysis? This is one among the MCQs, right? So now this question is talking about the racemization part. Now you already know racemization normally occurs in SN1 reaction. Okay, SN1 reaction wherein you get retention, right? Wherein you get retention plus inversion, right? 50% retention approximately you can talk about, and 50% inversion. So this gives a optically inactive product, right? So for the compound to be optically inactive, if it says retention and inversion, right? Correct. So for a compound to give this retention and inversion, the compound should be chiral. Am I right? So if you could see here, this is definitely not chiral. This option is not chiral because can you see two CH3 groups are attached over here? This is not chiral. This is benzyl chloride. This is chlorobenzene, and chlorobenzene basically does not undergo SN1, SN2, right? So you can just erase this out. And again, this is like primary alkyl halide, you can say. So this would undergo SN2 reaction. We are basically looking at SN1 reaction. Now we have two important things over here. One is the benzyl chloride, and then you have, I think this is 2-chlorobutane. 2-chlorobutane. So if you could see here, this is nothing but chiral, and this is a 2-degree alkyl halide, right? Correct. And if you could see here, this does not fit the bill at all, right? So the only option that's going to go is this option number 1, which is nothing but A, right? So the correct answer to this particular question is basically option A, which is nothing but 2-chlorobutane, right? 2-chlorobutane. So let me just highlight this over here as well, right? So I think this is pretty much simple to understand, pretty much easy to understand. Concepts of racemization are pretty much easy to handle as well, right? Okay. So now let's move on to the next part. Now identify the chiral molecule among the following. Now this is very easy question, right? So what exactly do you mean by a chiral compound or a chiral molecule? So chiral molecule is a molecule in which this carbon is tetrahedral, right? So this is connected to 4 different groups, right? A, B, C, and D. So I'll write here A, B. So this is carbon, right? A, B, C, and D, right? So if you could see here, 1-bromobutane, there is no possibility that it's going to be chiral. So I'm just going to spot this out, right? 1,1-dibromobutane, 2,3-dibromobutane, and 2-bromobutane. So let's start from this, right? 2-bromobutane. So but means 4 carbon, right? So bromine is at position number 2, and then there is hydrogen over here. So you have the CH3 over here, and this is going to be CH2, this is going to be CH3. So if you could see here, this is nothing but chiral, right? Correct. So this is basically chiral molecule. So I can say that D is correct. Now let's talk about C. C is dibromobutane. So you have but means 4 carbon, and there is going to be a bromine here, right? And there is going to be a bromine here. Correct. And there is going to be a CH3 here. There is going to be CH here, and I think there is going to be a CH here, and there is going to be a CH3 here. So if you could see here in all these cases, let's talk about this carbon. This is connected to one group, right? This is another group, this is another group, and this entire group, all 4 groups are different, right? So at least one chiral is fine as well, right? So I think option C also goes over here. So you have C and D. Now let's talk about 1,1-dibromobutane. Now 1,1-dibromobutane is going to be something like this. So if you could see here, you have hydrogens over here, correct? And this is carbon atom number 1, which consists of 2 bromine, correct? So definitely this is not going to be chiral. This is not going to be chiral. This is not going to be chiral. None of the carbons are chiral because the first carbon is connected to 2 bromine, and the criteria for chirality is that carbon should be connected to 4 different atoms or group of atoms, right? So I think B is incorrect and A is incorrect. So you can simply say that the correct answer is nothing but C and D. Okay, let me highlight this as well. Okay, so now let's move on to the next part. The next part is basically something like a word problem, very, very easy. Now let's try to extract the information first. Now you have an alkyl chloride on Wirtz reaction. Okay, so this is the first part. When you have a Wirtz reaction, the number of carbon atoms get doubled, right? So on Wirtz reaction, give 2,2,5,5 tetramethylhexane. Right, the same alkyl chloride on reduction with zinc copper couple. Okay, so this is basically a reduction. Now in reduction there is no change in number of carbon atom. Okay, it gives an alcohol reduction, in zinc copper couple in alcohol gives hydrocarbon with molecular formula C5H12. Okay, C5H12. Okay, so what does this actually mean, right? That after reduction you get C5H12. That means you can completely be sure of number of carbon atoms in the parent chain, that is alkyl chloride, is going to be 5, right? They have not decreased because reduction is not going to do any change with the number of carbon atoms. Okay, so this is just the information which we are trying to extract over here. Now let's try to see how we are going to solve this. So first of all, it's a Wirtz reaction. 2,2,5,5 tetramethyl means there are 4 methyl groups. Okay, 4 methyl groups, and then there is going to be a hexane. When you say a hexane, that means it's going to contain 6 carbon. So you have the total number of carbons. Total number of carbons are going to be 6 plus 4, which is equal to 10, right? So total number, this is in the Wirtz reaction, correct? This is in the Wirtz reaction. So parent is going to contain 10 by 2, which is equal to 5 carbon, and this is already known to you. Now you have C5H12, right? This is nothing but CnH2n plus 2, if you could see here, right? And here n is equal to 5. Am I right? So that means this is an alkane, right? So anyway, you don't need to bother about this. I'm just trying to verify the information about it. Now this structure is actually going to give you the final product, right? So first let's try to write down the structure. So you have hexane means 1 2 3, then you have 4, and then you have 5, and then you have 6, right? And 2, you have a methyl group, correct? And 2, again you have a methyl group, correct? So you have 1 2 3 4 5, and again there is going to be one methyl group over here, one methyl group over here, correct? So I'm just trying to solve this in a proper manner, step by step wise, instead of using any sort of shortcuts, right? So if you could see here, the molecule is pretty much symmetrical. So whenever you have a Wurtz reaction, you always know that you get a symmetrical molecule most of the time, provided that it's not a Fittig reaction or a Wurtz-Fittig reaction, something like that. So what I would recommend is now you try to break the molecule. So I'm going to break the molecule in such a way that I get two symmetrical halves, right? So if you could see here, this is one half, this is another half, right? Now what am I going to do is I'm just going to write this separately. So you have CH3, and then there is going to be C, there is going to be CH3, there is going to be a CH3 over here, and you have CH2Cl, right? So if you could see here, this is nothing but the alkyl halide, which actually goes with option A. So the correct answer to this particular question is nothing but option A, right? So you could simply see this if you don't want to go through the entire step, or let's say if this question appears in your entrance exam, how you are going to solve this? You know, 12, you already know that the final product contains 12 carbons, right? So that means there should be you can say 12 carbons over here, right? So looking at the structure, you can simply say that number of carbon atoms in the parent chain is going to be 6, right? So if you could see here, 1 2 3 4 and 5, this contains 5 carbon, right? This contains 5 carbon, right? 1 2 3 4 5 6. This is okay with 6 carbon. 1 2 3 4 4 carbon. So now the number of options get reduced over here. Now 5 carbon and 6 carbon. So if you could see here, you know, methyl group is at position number 2 and position number 3, and here you can say both the methyl groups are at the same carbon, right? So you can use these sort of strategies and actually solve the question. So that becomes pretty much handy over here. Okay, so now let's move on to the next question. Yeah. So butane nitrile could be prepared by using what? Okay, now the first important part, it's a nitrile, right? So if you could see here, this nitrile can be prepared using cyanide. Okay, now this cyanide contains 1 carbon. Butane nitrile means there has to be 4 carbon plus 1 nitrogen, right? So now let's try to solve this. Pretty much easy to understand. So butane nitrile means 4 carbon plus nitrogen, right? So you need to have a substrate that contains 3 carbon plus KCl, right? Substrate that contains 3 carbon plus KCl. So it has to be a chloride, right? So it has to be CH3, and then you have CH2, and then you have CH2Cl plus KCl. Correct. So the correct answer over here is option D. Alcohols cannot be used in this case. So I think this is pretty much simple. Okay, this is pretty much simple to understand. So the correct answer is obviously option D. So let me just highlight this. So the correct answer to this particular question is option D. Now, let's move on to the next part. Choose the compound from the following that's going to react fastest by SN1 reaction. Okay, so the key word over here is SN1. Now let's try to see SN1 reaction. What is the reactivity? The order of reactivity is 3 degree, 2 degree, and then 1 degree. Correct? Since all are alkyl halide. So if you could see here, this is nothing but a 1 degree. This is also 1 degree. Correct? 2-iodo 2-methyl butane is nothing but, let me change the color over here. So you have carbon, carbon, and there is one more carbon, there is one more carbon. So 2-iodo and then 2-methyl. So if you could see here, this is a 3 degree alkyl halide, right? So this is a 3 degree alkyl halide. So obviously, when you have 2-iodo 3-methyl, this is not a 3 degree. So let's try to write down that as well. So you have 2-iodo and then 3-methyl. So that means the hydrogen is going to be here, correct? Hydrogen is going to be here. So this is basically a 2 degree. So this is basically a 2 degree alkyl halide, correct? And this is basically a 3 degree alkyl halide. And we already know the order of reactivity is 3 degree, 2 degree, then you have 1 degree for SN1 reactions. Okay, so the correct answer is option C. Okay, let me just highlight this as well. So the correct answer to this particular question is obviously option C. Yes, so we have the reaction sequence with us now. So you have uh, cyclohexyl fluoride or chlorocyclohexane on treatment with magnesium. This is basically a Grignard reagent. So A is nothing but you have MgCl, right? And then this on treatment with water. We already know water is a protic solvent, and you know Grignard reagent normally gets deactivated or spoiled when you have a protic medium. Now there is a reason for it. So can you see this? The polarity of this particular Grignard reagent is going to be completely different than you might have thought about, right? So this is delta positive. The carbon becomes nucleophilic because it is attached to a metal. So H is going to go here, and finally you will be getting cyclohexane, right? So the correct answer to this particular question is obviously option D. Yeah, so this is basically the correct answer. Okay. Now, which of the following can be used as a source of dichlorocarbon? Yes. So this is pretty much simple to understand. If you could see here, this is also there in Rimmer-Tiemann reaction. Okay. So this is also there in Rimmer-Tiemann reaction. So, uh, dichlorocarbon, source of dichlorocarbon. So it's very much simple. So you have chloroform, right? Now chloroform on treatment with a base. Okay, so I'm going to write here OH minus. This OH minus is going to take up the proton. Electrons are going to be shifted over here. So what is that which you get? So you have the Cl over here and the lone pair with a negative charge. Now this Cl is going to go with the electron, as a result of which you will be getting carbon with one chlorine here, and a lone pair, right? So this is nothing but dichlorocarbene, right? So this is a dichlorocarbene. So the correct answer to this particular question is obviously option number 4, right? Option number 2, not option number 4. So let me just highlight this. So the correct answer to this particular question is option B. Okay, so we have two reactions with us, pretty much easy to understand. So if you could see here, this is Finkelstein's reaction, halogen exchange. So what's going to happen over here? So you have CH3, there's CH3 over here, and then you have a CH2. So this is going to have a halogen exchange. So Na and Cl will go in the form of NaCl, and then you will be left out with an iodine over here, right? Plus NaCl. So this is Finkelstein's reaction. Now this is also pretty much simple. This is nothing but Schwarz reaction, right? We have taken antimony trichloride over here. So you get CH3 and there is going to be CH2. There is going to be fluorine. Okay, ethyl fluoride is the correct answer. Yes, so let me just put this. Main product is going to be these two. It's very easy. Okay, so we have the next question with us. Pretty much simple, pretty much easy. So this is nothing but Anti-Markovnikov's effect, right? Anti-Markovnikov's effect, and these are pretty much simple as well. Correct. So what happens? The first one is going to be something like this: CH3. Then you have CH. There is going to be a CH3. There is going to be a CH double bond CH2. Now this on treatment with HBr, okay, what's going to happen? So in this case, you are using a peroxide. So we already know negative part is going to go to that carbon containing more number of hydrogens, right? So obviously Br is going to CH2 because this contains 2 hydrogen and this contains 1 hydrogen, and the addition is going to be across the double bond, right? So what is that which you get? So you have CH3, CH, there is going to be a CH3 and there is going to be CH, okay, CH2, and then you have a CH2Br because hydrogen is going to go over here, right? Now the next is pretty much simple. This OH is going to get converted into Cl. So what is the product? The product is going to be Cl plus SO2 plus HCl. Okay, let me show how it happened actually. So the bond breaks. Okay. So the bond breaks, one Cl comes here. This bond breaks, one Cl comes here, and SO goes over here. So here in this case, we have the byproducts, which are nothing but gas, right? Now here it's pretty much simple. The reaction is happening in dark. Okay. So in this case, you get a mixture of ortho and para chlorotoluene. Now, why is it that the reaction is not happening in the CH3 fragment? The reason is pretty much simple. The reaction is done in dark. Okay. So it doesn't have sufficient amount of energy to attack the sp3 carbon, right? So it's going to be ortho product plus para. Okay, so I hope this was pretty much simple and easy. Now identify the chiral molecule from the following. Now you already know what is a chiral molecule. A chiral molecule is of the type carbon with A, there is going to be B, and there is going to be X, and there is going to be Y, right? A carbon which is bonded to four different atoms or group of atoms. So if you could see here, let me just put this. So you have one group which is different, one group which is different, and then there is this hydrogen which is different. So this says that this is chiral, right? So now let's have a look at the second one. Can you see these two groups are similar over here, right? So this is not chiral. Again, this is not chiral because can you see CH2 fragment? And if you could see here CH3 and CH3, again, this is not chiral, right? So what is the correct answer? The correct answer over here is nothing but option A. So I'm going to write here answer is A. Okay, now the next is which one compound over here would undergo SN2 reaction faster from the other, right? SN2. Now, if you could see here, all are SN2 compatible, if you could understand this, right? All are SN2 compatible, and now there is a clue for doing this. And the clue is pretty much simple. The order of reactivity is iodine, then you have a bromine, then you have a chlorine, right? Fluorine is not at all there in the picture at all, right? So if you could see here, there is only one option that goes with it, right? And you also know the order of reactivity is nothing but 1 degree, then you have a 2 degree, then you have a 3 degree, right? So what happens over here? Very simple. So if you could see here, this is a 2 degree alkyl halide and this is 1 degree. And if you could see here, this is nothing but cyclic, right? So the answer over here is pretty much evident that it has to be an iodinated compound, right? So let me just write down this. So the correct answer to this particular question is nothing but option B. Okay, so the correct answer over here is option B. Okay, now we have this question. Again, it's easy, peroxide effect, right? So I'm just going to write here anti-Markovnikov, negative goes to more hydrogen, right? So what is that which you have? So you have CH3, CH double bond CH2 plus HBr. Now here we are doing a peroxide, right? We are doing a peroxide addition. So what's going to happen? Negative is going to go over here. So what is that which you get? You get CH3, CH2, and then there is going to be CH2Br. Correct. Now this is going to have a dehydrohalogenation. So let me just make a little bit modification over here. So I'm going to write here as CHH. So when you treat it with alcoholic KOH, so this is going to undergo dehydrohalogenation. So you will be getting CH3 and then you have CH double bond CH2, right? So this is nothing but your compound A and this is nothing but your compound B. Obviously, you have HBr and KOH is going to give us KBr plus H2. Very simple, very easy, right? So this is nothing but your A compound, correct? This is nothing but your A compound, and then you have a B compound as well, right? And this is your B compound. Very simple. Okay. So you have another sequence over here, red phosphorus and bromine. So what happens over here is you have CH3, CH double bond CH2, right? So this OH becomes Br over here, and then you have moist silver oxide, which is nothing but AgOH, right? So what happens? This Br and this Ag is going to go, and then you will be getting CH3, CH, okay, and there is going to be an OH over here, and then there is going to be a double bond CH2. Very simple to do it, right? Correct. So this is nothing but your A compound, and this is nothing but your B compound. Simple and easy. So let me just put this in the corresponding block. So this is A and this is B, right? Okay. So now the next one is very simple. So whenever you have a sodium and dry ether, it's pretty much evident that it's going to be a Wurtz reaction, right? So very simple way to do this Wurtz reaction. So you have CH3, there is going to be C, there is going to be a CH3 over here, and then you have a CH3, and then you have a CH2 with a Cl, right? I'm going to react it with metallic sodium, and I'm going to write this molecule but in a different way. Cl, and there will be a CH2, there is going to be C, there is going to be a CH3, there is going to be a CH3, and then there is going to be a CH3, right? So I'll need 2 Na over here, and the reaction has to be carried out in dry ether. So what happens over here is you get CH3. Now it's very simple. This is what it's going to happen, right? 2 NaCl will be released. So you'll be having C, there is going to be a CH3, there is going to be a CH3, and then there is going to be a CH2, there is going to be a CH2, and then I have C, and then I have a CH3, CH3, right? And then there's going to be a CH3 over here. So if you could see here, this is the longest chain. So 1, 2, 3, 4, 5, 6, right? So it's the same 2, 2, 5, 5. So if you could see here 1, this is 2, this is 3, 4, 5, and 6. Correct. So 2, 2, 5, 5, and tetramethyl hexane. Okay, so this is going to be the IUPAC name of the product. Okay, byproduct you can write it as -2 NaCl over here. Simple and easiest way to do it, right? Now this is simple Grignard addition. Now that anybody could do it, so you are going to get MgCl, right? Very simple Grignard reagent. So I'm just going to put this in a block. This is nothing but your A compound. Okay. Okay guys, so this is basically the part 1 of your topic. So this is basically the part 1 of your topic and HDA. Now stay tuned to see the updates and you can see the remaining part of the chapter. Okay, if you like this video, please hit the like button, and in order to get more periodic updates about the upcoming videos, please subscribe to my channel. Thank you very much and have a nice day.